New Horizons is the name of a mission to Pluto. It visited Pluto about 3 years ago. The beyond part is an object which is sometimes known as MU-69. That's the way I refer to it a lot. MU-69 was discovered long after New Horizons was launched. It was expected, it intended to visit something beyond Pluto, but they had to figure out later what that would be. So my background or description on how this comes about is not the way anybody else would have done it, I guess. I've not had any involvement in the mission, but I've rubbed elbows with a couple of people who have, and so my perspective on it is maybe a little different than other people. So I've broken into several sections. First of all was the history of finding Pluto. I think a little understanding of that, it goes a long way towards appreciating the mission. And then the question of what Pluto really is, the actual launch and mission to go to Pluto, and then the beyond part. I had to find the target, study it, and then the flyby is on Tuesday, January 1st. That's the reason for the timing here. Okay, so we start with Percival Lowell. He's a member of the very prominent Massachusetts family, graduated from Harvard. He was a businessman. He had quite a career as a statesman and author. And I think he decided he wanted to get into the science game. He was certainly competent in many ways, but he had this fascination with Mars. So he had money. He created an observatory near Flagstaff, Arizona. And the primary reason for selecting it was the quality of the sky. It's reported that he sort of set the pattern. Ever since, people realized if you wanted to look at the sky, go find a place where the sky is easy to see. At Flagstaff is over 7,000 feet elevation, and it's a dry country. So this is kind of, the Lowell Observatory was kind of the first one to set that pattern. Now we have them on top of Mauna Kea and then the high peaks in South America and so on. He was an avid observer of Mars, and he saw all kinds of canals, and he popularized that, and he was totally wrong. It's not altogether clear why he was seeing all this stuff, but a couple possible explanations. One was he had a very long focal length telescope, because that's where you get magnification. You wanted to see detail. Long tube, 15 feet long or something, and it was not ventilated. So it's speculated that he got air currents inside the tube, which are given all kinds of false images. It's distorting the light path from his objective lens to his eyepiece, which is the order of 15 feet. Another possible explanation was he was really seeing the veins of his eyeball. Okay. Anyhow, we're pretty convinced the canals are not there. He thought they were, and he was very aggressive about that. But he kind of changed his mind. About 1905, he decided to devote himself to finding planet X. Now, that's always confused me back in the stories. I think of X as being an unknown, but also the Roman number 10. Well, we had 8 planets, so what he's looking for is planet 9, but he called it planet X. So anyhow, the observatory is still there. It's growing. It does a lot of good work. And still the family connection. The trustee is a great-grandnephew of the founder. And you see he's got that 4 in there. It's part of the family tradition. Okay, why was he looking for the planet? Before Galileo, we knew about 6 planets. And we couldn't see any of the others because they're too faint. And it was 170 years after Galileo when they found the next planet, Uranus. And its magnitude 5.8 is right at the limit of what the unaided eye can see. That is pre-Galileo. In principle, it could have seen it, but not well enough to identify it and have it pick out. So it took 170 years for somebody to come up and find it was there. It's 19 AU from the Sun, astronomical units. Jupiter is 5 AU and Saturn's about 10. So Uranus is out there a long way. It takes 84 years to go around the Sun once. But the key thing was that it was observed after watching it for a while that the orbit was not particularly uniform. There's some irregularities in it, and the mathematician got busy, and in the mid-century, the 19th century, he did calculations predicting that there was another object out there that was influencing Uranus. And then he had a little trouble convincing people that that was real, but when he did, in a matter of months, they found it. They found Neptune. And it was magnitude 7.9, well beyond what anybody could see without a telescope. And then it's another step out, 30 AU out instead of 19. Its orbit's about twice as long, 165 years. Okay, this, I believe, was what got Percival Lowell interested. There's irregularities in Uranus, you find Neptune. Irregularities in Neptune, go find what's causing it. So he went and did mathematics, and he decided that should find another planet. There's planet X out there somewhere. Okay, he died in about 1910. That is, Lowell died before this had gotten along very long. And the settling of his estate was a very complicated, long thing. And I noticed in the history when he finally did get it wrapped up in 1927, the trustee involved was his brother, who happened to be the president of Harvard. You can see the family connections and the history of the Boston area and so on there. But he gave the go-ahead to get back and look for this planet, Planet X. So it was discovered in 1930 based on two possible calculations that Lowell had done, and the one he thought the more likely was one that turned out to be where they found the planet. Since 1930, Neptune has made one orbit, and Pluto has made 1/3 of an orbit. So we're kind of early in the history of these planets in that sense. Okay, Clyde Tombaugh was the guy who did the discovery. He was a farm boy, unable to go to college because the crop had failed, and so he was 21 years old or so and working on the farm, but he's very interested in astronomy, and he built himself a telescope, and he used spare parts. And he made sketches of Jupiter and Mars, and he sent these things to Lowell Observatory. And I was thinking, why did he pick Lowell Observatory? So I took a check. He was about 800 to 1,000 miles from there, so I don't know he had any particular connection at all, but that's where he did. And the response to his sketches was not an opinion on the quality, but rather a job offer. They had been for a year in the position to pursue this search for Planet X, but they didn't have the resources, or the people were committed to other things. They decided they should go get a full-time employee to concentrate on the search. And so he got the offer. And then I attended one of his after-dinner talks I'll describe a little later. But in the process of that, he said that part of the interview process was asked about his health and established he was a good husky, not an invalid or anything. And he said that the basic reason there apparently is because he had this job to shovel the snow in the winter. A little supplement to his astronomy observing. When he got started, he didn't go very long before he saw there were lots of problems. And I think probably mostly connection with having a dirty, dark room, that sort of thing, was not getting the quality of things. So everything stood down, and he cleaned things up. He got his procedures going. He was tied to the moon schedule. You can't do deep space sighting if the moon's up very much. So worked that out. And then 10 months later, he had found this thing. And then the rest of his career, he was, World War II came along. He was teaching navigation to Navy personnel. Later he went to White Sands Missile Range, and then ended up teaching at New Mexico State. He had lots of other places too, but his last career was in Las Cruces. And he had lots of other things astronomical to his credit. And I suppose that by now his telescope has has gone to Smithsonian, but I couldn't find a confirmation on that. There down in the lower left, you can see some of the parts, gears and so on. His telescope, I'm sure, had no clock drive. Myself, I had my first telescope I had for 10 or 15 years before I was able to feel I could pony up the money to have a clock drive added to it. And he was, of course, 30 years ahead of me or something. And so that's the scope that he had built, that he did the observation, got him the job at Lowell Observatory. Then everybody knows the story. The blink comparator was the key thing to find the changes. So this is the blink comparator as it was on display in the Smithsonian for some time. It has since been returned to Lowell Observatory. But here it is to give an idea of the size. There it is on the floor with people at the Smithsonian. And here it is up close. And you can see that the eyepiece is here. Here's one film. Here's another. So they've got optical system here that looks at this film. Optical system here looks at this one. And then there's a mirror flip kind of thing in here, so we can look at this one and that one alternately. I didn't find a description for the details, but I assume he was mechanically flipping the switch. I don't think he had any automatic timer or anything like that. You can see a screw up toward the top here, so this eyepiece would have cranked up and down to look at different parts, and I believe based on this looks to me like slides, so that the whole thing, the eyepieces stay fixed, and all the rest of the carriage could go left, right. So I could look at this part, that part. Then I brought along a little sample here. This is 2 sheets of 2 pages of legal size paper. That's the size of one of those pieces of film. Not quite in the 35 millimeter category. This is they called it an astrograph, was the optical system he was using, and this is the size of the film that was involved. Okay, this is the discovery. Now I'm going to try a little experiment here. If I do this right, I can come down here. Okay, now let's see. That is a portion of the discovery film. It's blinking. This is on a cycle, a 1 second cycle. As I say, I think he would mechanically, at his own pace, whatever he wanted, he would flip from one to the other. So the question is, can you find the 2 images of Pluto in there? And if you take a look right up here, in the upper part is a star that keeps coming and going and coming and going. That's not it. Here you can see this one kind of is there all the time. It's a little different in the 2. This bright one here is brighter one time than the other. The 2 exposures were intended to be identical, but the sky quality is not the same, so the 2 images are not the same. This is what he had to deal with just the best he could. What it comes down to is, this is one of the images right there, and the other one is right here. Becomes a little more obvious once it's pointed out. But this is a small part of the plates. These 2 plates were taken 6 days apart. And then after it looked like one of the clues here, when he did find those 2 that were on one plate and then the other, the space between them was consistent with something you would expect for the 6 days elapsed. After all, he's looking out in the plane of the ecliptic, and so you know something. You make some assumptions whether it's going to take 100 years to go around or 500 years or something to move about so far. So that is consistent, the direction and the distance. He would have had that as a kind of a backup to give confidence. But then, after he got these 2 on the 23rd and the 29th of January, he's looking at it in February, incidentally. He then found another plate a couple of weeks from this that confirmed that. Then he had the 3 plates that confirmed the location of Pluto. See, now I have to find my way back to that? He looked, they estimate he looked at millions of stars in the course of 10 months in order to find that pair. So this is part of what we're looking at there, dynamic. The two images are fixed and have the arrows pointing there. Okay, then while we're at it, some years later, it was discovered that Charon was a satellite of Pluto, and this is a small part of its discovery image. And what happened there is, it's the black part is what they were seeing, what they got on a photographic plate for Pluto, and a little bump towards the upper right there was Charon poking around the corner. So the fact that this was not really circular, was distorted, was the clue. Hey, there's something else there. So that was 1978, not so long ago. And that's when Charon was discovered. Okay, my personal contact with any of this dates from this conference in 1988 in the LA area. I've been a long-time member of IOTA and ALPO and several other organizations had their meetings all together there on one weekend because of something was happening, like an insight or something. I don't remember what it was, something out in space. So they had this central thing. And as part of that, I took a tour of the Mount Palomar Observatory. A bus load went down. And the nice thing about that was we were in on the floor of the observatory around the mount and so on, where the people who just dropped in for the day were up in the balcony. We had a guided tour in the midst of it. It was kind of nice. But then the other memorable part was the after-dinner talk by Clyde Tombaugh. And his topic was, why is Pluto a planet? And he was anticipating the arguments that came up 20 years later or so. And not a surprise, you know. It's but it was a very, very interesting talk. He was a very convincing speaker. Then after that, he was immediately followed by Dr. David Dunham, whom I've known for 40 years or so. And his daytime job is calculating trajectories for these various missions. He worked for most of the time, he worked for Johns Hopkins University, more specifically their Applied Physics Laboratory, which is the contractor for a lot of this kind of thing. So he had this 3-minute or 5-minute little talk afterwards. For him, it was probably a back-of-the-envelope calculation to describe when you have a chance to go and visit Pluto. And the thing is, it turns out your windows of opportunities come up about every 12 years because that's the orbit time of Jupiter. In order to get there with a modest amount of fuel, so on, you have to use a gravity assist from Jupiter. Well, Jupiter has to be someplace in this general direction so that when you go by it, it sends you off towards where Pluto is. Well, if it's 180 degrees, if it's 6 years out of whack, you won't have enough energy. You won't get any benefit from Jupiter. And so I suspect out of the 12-year orbit, there's probably a year or two where it works to line up to Pluto. I don't know exactly the numbers, but anyhow, that was the restraint. So my recollection was that he thought that this is 1988 at the conference. He was speculating he could launch something in 1995 would be a window of opportunity. There was no budget or anything, no plans, but he just described that. It was kind of nice. This just right after the presentation by Tombaugh. So then, in addition to having opportunities, a window every 12 years, you're also dealing with the window of opportunity for Pluto with this 248-year orbit time. While it's close to the sun, it's going to be heating up so that it has an atmosphere. By then, they knew it had an atmosphere of sorts, but it's speculated that as it got further from the sun, and it varies a lot from 30 AU to 40 AU. So as it got further away from the sun, it's speculated all that atmospheric stuff would condense and precipitate out on the surface, and you wouldn't see the atmosphere. So the science involved would be less interesting. Well, okay, closest approach was in, I guess I didn't write it here, I think it was about 1988 or so, when Pluto was closest to the sun. So every year is getting further away. If you wait another 12 years or so, it's going to be so far away it may be too cold and not of as much interest. Then a little later I found a reference to somebody at NASA approached Tom Bow and asked if it was okay to go and visit Pluto, and he said, yeah, but it'd be a long, cold trip. About 5 years after that conference, they started finding things out beyond Pluto, and ended up with the classification of trans-Neptunian objects, or TNOs, because the furthest thing out in the solar system we had was Neptune and then Pluto. Well, now we're finding lots of other things, and I ended up calling the region the Kuiper Belt. So now the controversy, is Jupiter a planet or just another TNO? And so that's something to argue about and discuss. And then we get into serious talk. They had plans for a space mission to Pluto that was canceled in 2000. I don't remember any of the story, the details on that. Basically, it just got to be so expensive they canceled it. They went through a period there then, rather briefly, where it looked like there'd be no expedition to Pluto at all, because they're about to lose this launch window opportunity in 2006. But a fellow by the name of Alan Stern got real busy promoting one thing and another, and came up with alternative enough to convince NASA to issue an RFP with specifications that he had calculated they could match. This is in 2001. Alan Stern was the name. It turns out he's the principal investigator for New Horizons. But he was in there doing the promoting and looking for the money, and he got it. The criteria in the RFP specified launch by that January of 2006 and arrive by 2015. Okay, they got more than one proposal, but New Horizons was the one that was selected. That was in November 2001. And it was awarded to Johns Hopkins University, their Applied Physics Laboratory, and Southwest Research Institute. That organization is based in Texas, but for this kind of work, their main office is in Boulder, Colorado. And then twice it was, over the next couple of years, it was deleted from the budget and restored. Johns Hopkins University is in Maryland, and the Maryland senator got the money restored. Then another thing, it was very critical, almost killed the mission. Going out that far, you cannot use solar panels, they're not efficient enough. So they used the thermonuclear generator, which requires plutonium oxide pellets. And this was through a period of time when Los Alamos was going through a bunch of problems with security complaints and changing contractor and so on. So they quit making this stuff. But to be able to put it together, the mission had designed said they needed 220 watts to start with, but they compromised since they could only get 200 watts worth. That's enough, and they did it. But it was kind of touch and go. Package is sort of the size of a grand piano, weighs a couple 1,000 pounds, has 7 experiments on it for optical and various things. And none of them are new experiments. This is sort of tried and true stuff. And then another part of the requirement was, besides getting to Pluto by 2015, have the capability to go and do something else, which is very undefined, but that's where we are now. Okay, in 2005, a new planet was discovered, which ended up being named Eris. That was a Caltech team. They used a telescope on Mount Palomar. The leader was Mike Brown. The new object they found was very similar size in Pluto, but it was much further out, about twice as far. And this raises the whole question. Did we find a 10th planet? And so I read a couple of the interviews with Mike Brown and so on, And so here he is in this position that he didn't think it should be a planet. Same time, it'd be kind of nice to go down in history like Tombaugh had. He became discoverer of 10th planet. You can see mixed emotions on this sort of thing. But the result was, in 2006, the International Astronomical Union decided to be a new category called dwarf planet. And they had 5 objects at that point. Pluto and Eros were the largest. Pluto's slightly bigger diameter than Eris, but it's not as much mass. Very similar. Criteria for a dwarf for a planet was to be massive enough to form itself into a sphere by gravitational attraction and also clear the region. So the dwarf planets didn't have to have that clearing the region requirement. Back then, 4 years later, Mike Brown put a book in 2010, the title, Why I Killed Pluto and Why It Had It Coming. And I read that book a year or two after it came out. I haven't recently, but it's kind of interesting. He's kind of realistic, and his basic position throughout the book and still is that everything outside of Neptune is debris and not a planet. And that's what IAU adopted. There have been new arguments trying to reverse that and so on. But it doesn't really matter. Another thing that Mike Brown said, which makes a lot of sense, it's a name. You're trying to classify things. So think of it as parallel to a continent. Is Greenland a continent? Well, it's just we decide it's not, but it could have been. Where do you have the cutoff? And so the present position, we have 8 planets, and then we got debris. And that's sort of what it looks like. The sun in the center there, the initials for Jupiter, Saturn, Uranus, and Neptune, the various distance out further and further. Then outside that, you end up with this Kuiper belt. And they have different color codes for different types of things in there. But that's the way our solar system looks now. They're out in the blue dots and so on. I think that actually Eris is up out at the far edge, and Pluto is sort of the inner of the edge here. Let's see what else I've got. Here are the largest TNOs that are known now, and now Pluto has 5 moons. It discovered Charon in 1978. Since then, it discovered 4 more, and Eris has 1 moon. Haumea has 2 moons. Of the biggest 7, all except one of them have 1 or more moons. And all these things are fairly small. Pluto is about 1/6 the diameter of the Earth. It's not a heck of a lot bigger than the moon, than the Earth's moon. Down at the bottom, you see to scale the Earth and the Earth's moon. So that kind of gives you the size relationship. Here is to put things into a different perspective. Here they've divided up the pie for mass. Moon's got a bigger chunk than any of the rest, and Eris and Pluto are about equal. Then these others are smaller and smaller. But think of it, I don't remember what the number is, but the moon's mass is like 100th of that of the Earth or something. It's really, these are pretty small compared to the other planets. This gives an idea of the relative sizes and the albedos. Albedo is the astronomer's term for reflectivity, is the way I look at it. When they find an object, they measure how bright it is. Then you use kind of an assumption of an albedo of such and such, and that tells them how big the thing is. If it turns out it's brighter, then the object was really smaller, and so on. It's just a guess. You can see the albedo is changing a lot here down. These 2 are quite dark. This is very bright. And then the brightness may change as it rotates too. So it's kind of a mishmash of things you have to put together, but that's what it takes to learn. Here is an interesting picture showing Pluto and Charon to scale against the Earth. It shows the shadows of the 2 of them in addition to themselves. Kind of gives you an indication. Venus is slightly smaller than the Earth. Mars is smaller than the Earth. Mercury is much smaller, but there are four of the planets, the gas giants, are huge compared to Earth. Then, interesting way to think of this is what fascinated me is how close together these are. Not as close as they're shown here, but if I were to take Pluto and drag it up to the corner here, and take Charon and drag it down to this corner, that would be approximately their realistic separation. They are so close together, very close together, and they orbit about each other. Okay, now the mission, New Horizons mission. Competition was awarded in 2001. They launched less than 5 years later. One of the key things, they started out with 200 watts of electrical power and with 75 kilograms of propellant. And this propellant is for steering, not for launching, but after they got into orbit, that's the propellant they had to do their course corrections and so on. The power is decaying, I think, with a half-life of 3.5 years or something. Anyway, I guess it's slower than that. And anyhow, it goes down. So you can see as the years go by, there's less and less power. And they figure around 150 watts is the minimum to continue to do any scientific experimentation at all, and also operate the radio business to get the information back. And their ability to maneuver and get into position and so on is limited by propellant. So by next week, when it has its flyby, they expect it will, well, right now it has about 21 kilograms of propellant. By the time it's done its maneuver over the next week, it'll be down to 9. So it's very limited what it can do beyond that. But it will have that mission out of the way. It got there with enough to get in position. They're going to fly by at about 2,000 miles from MU-69. There was about 6,000 miles past Pluto that they went. They stay away from them that far because of the concern for any debris and so on. They've done all kinds of searches to look for various things that would be a jeopardy. They haven't found it. And based on that, they decided to make the pass at about 2,000 miles instead of 6,000. And so they're pretty well committed now. It only lasts 3 days until this thing happens. So this is the Kuiper Extended mission. Pluto was the main mission. The supplemental was the Kuiper Extended mission. One more thing I would describe here, the bottom line there, in 2032, another 12, 13 years away, the power will be down 150 watts. I figure that's really the limit, what they can do anything. Meanwhile, they may do some minor triangulation experiments and so on with the Voyager craft and so on. So, and in 2032, it'll be out 82 astronomical units. It's around 40 now, so it's going to be coasting a long time. And this flyby next week will make it far and away the most distant object that's been visited by any spacecraft.
How far out is Voyager?
Okay, this is a logo that's used for New Horizons. I worked with the Nevada test site and underground testing and so on a lot, and for each one of our events we'd end up with a logo of some sort, if nothing else, just to label parts and keep track of things. And also it's a little team building thing and so on, but a little information for it too. You notice it has NASA's name. Basically they provided the money. Southwest Research Institute is one of the prime contractors. Johns Hopkins University Applied Physics Laboratory is the other main contractor. I believe they primarily provide the vehicle, and Southwest Research Institute provides the instrumentation. The Department of Defense is on here, I'm sure, because they provided the plutonium dioxide to provide the thermonuclear generation of power. And I'm not sure why JPL is on there, but they have a long history of controlling these things, and so I'm not surprised they're involved too. Here is the thing on a dolly on a media day. This is two months before the launch. Big antenna, lots of stuff, gold foil involved there. This is a little aluminum canister that's attached. It has some of Tombaw's ashes with a caption on there identifying him in terms of his parents, his wife, and his children. So he got to visit Pluto. This was a launch in January 2006, a Delta V rocket. This, and of course, it took 13 months to get for their flyby, their gravity assist from Jupiter. And as it went by Jupiter, good chance to test out the instrument. These are images from that. These are this is Io and this is Ganymede, two of the moons of Jupiter. This is a shadow of Io, and this is the shadow of Ganymede. So the instrumentation's all working. This is pretty obviously a spherical body. You might think it's a marble, except you don't think we'd show it here today. Turns out, prior to the launch of New Horizons, this is the best image they had of Pluto. You could say, okay, it's not uniform color, it is a sphere, and that's about all you could say. This is what they saw then as they were approaching. This is Pluto with limited corrections. And one thing that's caught people's eye in a hurry, there's this object here that's kind of shaped like a heart. Okay, this is called it's a Sputnik something. They labeled this area Sputnik. But now, officially a year ago, this whole object was renamed for Tombaugh. Tombaugh Regio. Oh, thank you, Kevin. Here's my problem. The Regio is from the Latin for region. So it's the Tombaugh region of Pluto. This is color corrected. The camera system, they transmit the raw data back and they have various corrections thing. Then they, after they get it, they can clean it up. So this is basic same thing with more detail. And of course, this is a flyby. You see it for weeks in advance, but you keep getting closer and closer. And then you take your best shot and you put them together and so on. And you can now see this Tombaugh Regio kind of has two sections. This one is smoother than that and so on. But someplace in here, I think next one shows, there's a mountain range in there that has heights of 11,000 feet, which is comparable to the Rockies, except this planet is much, much smaller. So these are really big irregularities compared to the full size of Pluto. And they got good detail. Their instrumentation is working. And here it shows Charon and Pluto together. And I think that doesn't show really their actual separation. That's superimposed, I think. I couldn't really establish that. But they both have quite different colorations over their surface. Of 10 images taken over 10 days as it was approaching Pluto. And as they're going by, Pluto is rotating, they're getting closer, so they had to do lots of resizing, scaling to make these all look the same size. But here you can see the Tombaugh Regio. There it's further to the left. Even further now, it goes about out of sight. It's rotating around as they got by. Right, let's see, there's a little here's a prominent crater you can see. And there it is here. It just barely is visible, so it's there. It's rotated around to here, then to there. There's that crater, there's that crater. It's about gone. So they got about one rotation of Pluto in view as they flew by, that within range where they could get good quality photos. Then it's just a month ago that some of us took a look at the InSight arriving at Mars, and I thought it'd be kind of compare the New Horizons InSight. They had very different objectives, and so here are some of the differences I thought would be interesting. Starting out, do you land or do you fly by? That's quite different. Took them 6 months to get there for InSight. They're up to 9 years now, almost 13 years to get the MU-69. So the whole scale of things is different. The distance from Earth was Mars happened to be just right at 1 astronomical unit away, and we're dealing with 32 for Pluto and 44 now for MU69. And the communication, you remember waiting for things to happen 8 minutes. Here it's 4.5 hours now. It's 6 hours for this thing that's coming up. Whole different, same kind of problems, just the scale is different. Okay, then it's a little of a deviation of sorts. Recon is a thing I'll be describing here. That's their logo. It's an acronym for Research and Education Collaborative Occultation Network. Some of you know I've been tied up with occultations for years, and a couple months ago I gave a rundown on my trip out to visit to record an occultation by an asteroid called Sappho. This is doing the same kind of thing, but it's the brainchild of Mark Buey at Southwest Research Institute. He has put it together. Each site is in a community, preferably a small town, and they have local teachers or something and students that run the thing for them. What he ended up doing, he got funding to create about 50 stations. Right up here is the Canadian border. The third station down is my old hometown, small town of a couple thousand people, and they got some teachers and students and a telescope, put them together. They have a station. Down here is Carson City. They've got a team there. I think this is Tonopah. They've got a team there. It goes all the way down near Yuma. About 50 stations. On the rain shadow side of the Cascades and the Sierra, where the sky is relatively dry and clear, and to have all these teams now bring an occultation to them. The picket fence is there, and they get alerts when there's something that Mark Buey wants to know about, and they'll get their teams out, and maybe it'll involve just these stations, maybe just those stations, depending on where the path is. But he's got these things out there ready to do that. This is the way each one was equipped. This scope is very much like my scope, except it's bigger. Mine's an 8-inch, these are 12-inch. And so it cost an extra $1,000 or so. They provided a video camera for each one. They standardized on the type of camera. They provided them a time inserter, which I sold to them. I sold them about 50 of the time inserters that I built. And so each one of them was equipped with that. They gave him a laptop computer in order to communicate and to record the video. So that $5,000, he equipped each of these 50 stations, and he has his network built in there. And it was really quite an organizing effort and very successful. And this shows a Carson City pilot program. They got people from several nearby communities to come together for a weekend of training on what to do with this thing. So this is not the Carson City delegation. It's the delegation from several cities in the vicinity of Carson City. And Mark Buey's right here with a beard. Okay, this is a discovery image of MU69. Discovered using the Hubble Space Telescope. 2 bright stars here with a reference. Then they've added the little circles here. Each image inside a circle is 10 minutes later than the predecessor. So that's 50 minutes of exposure time, or 50 exposures separated over 50 minutes, showing this object, which they end up calling MU69, and moving along there. So he's discovered an object in the Kuiper belt that, based on the visual, by the photographic brightness, it's in the range of something they're interested in. This is one of his prospects. That's something he might visit after they visit Pluto. This was discovered in 2014, a year before New Horizons went past Pluto. Okay, now we're seeing the Kuiper belt again around the solar system. The Pluto's path, you see, is not nearly as circular as the others. So this is what I was referencing. Pluto was closest to the sun in about 1988, I think it was. Now it's out here. It's getting away further, so it's getting colder. And then MU69 is this orange a red circle going around kind of through the middle of the Kuiper Belt. There's Eris up here. Somebody asked about that. Here are a couple more of the Kuiper Belt, the larger objects. MU-69 is not one of the large ones. They didn't want a large one. The large ones are the size of Pluto. They wanted something smaller. That's different. And so at the time of launch in 2000, that was 2006, it was assumed that they'd have a dozen candidates who would be able to find a dozen things to look at after Pluto. Okay, what's happening here? He had to make his gravity assist from Jupiter, which would be this orbit, go by Pluto, and then encounter something here. Well, this is not the way they're lined up. By now, Pluto's up here. So, there's windage involved, and that's routine for people like David Dunham and so on to calculate. But that's what's going on. This is a little different view of it. It's a little scale. And so this shows that this trajectory, Pluto is no longer in the trajectory because time's gone by, and they're down here now at MU-69. Pluto was here 3 years ago when they went by, and now it's moved on. As I recall, the major planets, Saturn, Uranus, Jupiter, and so on, we know they're in a fairly well-confined plane. Not precise, but fairly well-confined. And Pluto agrees with that less. I think its plane does not match as well, but in general, it's kind of the same. I didn't find a graphic for that. But at this point, I've kind of backed up. I showed you the recon group. This is a team that can observe these things from the Canadian border to the Mexican border down through Washington, Oregon, California, Nevada, Arizona. But I showed you the image. They found in a space telescope. They found MU-69 as a candidate. And then after a year or so, that was 2014. So by 2016, they decided MU-69 is the one they're going to use. They found two others that were possible, but this one, I don't know what the criteria was. Ease of getting there, the size, I think, was the main consideration. So they needed to know something more. How accurately can they find the location? There's a little blip on film is what it is, and so you got coordinates, but only about so good. The size is assumed by assuming an albedo. So they didn't really know how big it was. They knew it wasn't as big as Pluto or anything. So the tool that was left to look at it, the telescopes can't see these things except as a blip of light. Stellar occultations. You observe the shadow of the object passing Earth. You find a star. I think the stars they found were magnitude 15 and 17 that were going to be occulted by this thing and going to cross the path. Here is, I'm kind of jumping ahead here. This is one artist's idea of what MU-69 might be. This is the nucleus of the Rosetta target, which was I forget how to pronounce the name, but Gerasimenko, I know that part of it. This is the asteroid that was visited 3 or 4 years ago. They put an object around and actually landed on it and so on. But it is small compared to MU-69. That's the point here. Okay, so they had 3 occultation opportunities came up in 2017 to measure MU-69 by observing with modest-sized telescope, the recon type of thing. The first one is going to be in June. It's going to cross the tip of South Africa and then pretty well south of South America. And we're looking at it from the viewpoint of the star that's there. So you can see this is, when you get clear around to the edge, it's going to be really low on the horizon. If you stay in the middle part of this, you're looking up higher in the sky, and that's good. So both of those were not too bad. They're not too close to the horizon. This one a little better than that. And the star was going to be magnitude 15. And so they deployed. This is from one of Mark Buey's presentations. He summarized what happened. They were able to get 22 portable telescopes sent, and they in South Africa they were able to get 3 more. They had a total of 25. A mirror broke on one of them. They actually fielded 24, and roughly half of them were in South Africa, half of them in South America, and nobody had a positive occultation. It was a miss on all 22 stations, 24 stations. But they knew the miss wasn't very big. What is pointed out is they still did not know exactly where MU-69 is. That is to the scale of a few hundred miles on the Earth's surface. There was, but a positive, they did not see anything to indicate that there are satellites or junk around MU-69, which caused some dimming without actually causing occultation. So that was good. Second occultation was about 5 weeks later. It was passing over the Pacific. And no place you could ship your portable telescopes out to do that. You couldn't hire an ocean liner to go and sit on it and so on. And the target, again, not bad, magnitude 15. That's beyond what I can do with my scope, but not hugely beyond. So they gave that a try. And the object was to look for diffuse things, get a solid body occultation if they could. That would be a bonus. But the target, okay, I didn't mention, was Sophia. It's the 747 that's equipped as a flying observatory. So I was at a presentation given by Mark Beer. He was describing this thing, and he got to fly on Sophia for this. But he said he was kind of surprised. He got to Christchurch, New Zealand, with this criteria, never expecting him so on, and he went to the pilot and said, okay, here's what I need. Gee, they'd never had a request like this before. He wanted a time and place with precision that was, so it took him a while to kind of figure out how to do it. He assumed to be routine for him. It was not, but they did. They managed it. And so they took off from Christchurch. They flew out, generally north. Then on the way back, they list the things here. These are stars they're doing the reference to come in. The upshot is someplace in here was where they were to intercept the shadow path. And his previous view graph there indicates he came within 1 or 2 kilometers of the location within a second of the correct time flying in this airplane. They did not see a solid body occultation, but they saw no diffuse material either. So, and he did get the aircraft where he wanted it. He showed a photo of himself going up the stairway into the 747. It's quite a climb to get up into the thing. He said it's very unusual. Experimenters normally don't get to go on the airplane. The experimenter, somebody gives them the money, the time to fly the airplane, but then the crew goes and does it, and they sit and twiddle their thumbs and chew their fingernails and so on until they come back. In this case, he flew with it. Because weather prospects at Christchurch were not good. If it take them, 10, 15 hours or something to do this kind of flight, when they returned, they might not be able to land at Christchurch. So their alternate was Auckland, up in the North Island of New Zealand. And so if that was the alternative, he had 5 days to get to South America for the next event with this one, July 10 to July 17. This third one was way down in the tip of South America, further south than that one 5 weeks, 6 weeks earlier. This was in the summer of 2017. They put out calls asking for volunteers to go and man these stations for this and this in about February or so of 2017. And I had done this kind of thing, and I thought this would be pretty neat. This is a really good, important to get to use a bigger telescope, etc. But I'm too old for that. 10 years ago it would have been. And then I realized it's going to be winter down there. They had some really miserable weather here. But they fielded about 20 stations, and this view, the yellow dots marked positive, a disappearance or a reappearance. They had lots of misses, but they were pretty well centered on where the path was. The ones that got hits were pretty much in the middle of it. The next view graph shows just those middle ones with a little more accurate, showing where the star disappeared. These are plots in time, but you can also visualize them in displacement or distance because, the velocity of the shadow. So they put a couple faint circles on here. I don't think you can see them very well, so I boosted them up. So one explanation is that maybe it's a couple objects that are in contact. Another explanation is that it's an irregular object of some sort. Don't know. But now they have a pretty good handle on the size. This distance from here to here is known probably to a few meters. The accuracy of the timing is good enough that, this is now the order of a 20-mile long body. That they know now to an accuracy of 5% or so. Don't know the shape, but they know what they're looking for. Another thing they learned was that the body was smaller than they expected based on an average albedo. Therefore, it's brighter than they thought. So that allowed them to make change their plans for setting their camera exposures. After all, when you're dealing with a 6-hour delay, you got to anticipate things in advance. So the change in exposure was a result of finding the size of this thing. And another thing they did was to slow the travel of it. It's a year and a half from this occultation until the flyby next week. And so they delayed its arrival, the flyby, by 1 hour, shortened the 1.5-year interval by 1 hour. Turns out the reason for that was to get the optimum position of the ground radio communication links, get them in the right position. They've got more than one station, but arriving an hour later than they'd planned, the rotation of Earth and so on would line up better. So here's an artist's idea. If it's a single object, it might look like that. If it's two objects, it might look like that. And this is showing it with this Rosetta target for size. It's much bigger. This is a photograph of Vesta, which I threw in just because the features on it and so on kind of remind me of what the artist is showing. And so where did he get his ideas? And so maybe this is what it is, don't know. This is showing the size projected on Cape Cod Bay. So that's just another way to show the perspective. And right here is the Rosetta target, just for a size comparison. This is how the MU-69 will appear to brighten as it approaches. Okay, we're back several years. It's magnitude 23. By the beginning of this year, September of this year, it's up to magnitude 20. 1st of December, it's up to magnitude 18. About a week ago, it passed magnitude 15. It's going to be to New Horizons. It's going to look as bright as Vega, or one of our first magnitude stars, here in the next couple days as they get much closer. So this is my final slide. The approach phrase, this final extended mission thing, have the various phases. The approach from last August up to last week. Then from December 24th to the 2nd is the core phase where they actually passed by. They're expecting, I think it's about 4 in the morning for us when it's closest approached. Anyhow, for Pacific time, 3 in the afternoon is when they expect the first photo. And I think it's the next day they expect what they call the New York Times photo, a quality that they'll really want to publicize. Departure phase, then a bunch of things they do as they're leaving. They're still primarily gathering data. Then they have a 20-month interval to download all the data. The communication link is kind of minimum power, and it takes time. It took them only about 15 months to do all the download from the flyby of Pluto. It'll take 20 months to do this one. And then the mission ends. That's when the money runs out, according to present funding. And that's at the end of the 20 months. That's when they should have their data down. But there's enough power, conceivably it can go for another 12 years or so. And so it'll be interesting to see what happens. They may never hear from it again, but I suspect, like Voyager, it'll be checking in from time to time.